Hello. Okay. Good evening, everyone. Right, so I think similar people are there. Okay, fine. So today's week 8 solve with us. I hope you all of you have prepared with the week 8 content, right? So some of the questions will be there. We'll have to solve those, and then I think this week also again we'll be having the uh, revision session for all of these weeks. So shall we start? Okay. You wanted a rest. You can take a rest, right? I will record the meeting and then you can watch it later. Or you wanted me to get rest. What are the chances that India will win today? Okay, fine. So, are you guys aware? Are there yes, no? Can you can just thumbs up also. That means I'll get to know that you guys are here and listening to my voice. One is there. Others they just joined the meeting. Okay, two, three, four. Yes. Okay. Fine. Okay. That. So shall we start? This is the question. The first question is the following table represents the data set of 10 objects with attributes color, type, origin, and the class. Okay. Uh, Whether the customer who bought was satisfied or not. So class in the sense that is a label, right? So that is a label where there are two categories, which is yes and no. In the label, we have the three uh, variables: color, type, and origin. These are the attributes or the input features, and the satisfied or not is the uh, output feature or label. We want to classify a new object with the following new properties. That is color equals to red, origin equals to domestic, and type equal to formal. So what is this? This is the X test, right? X test data point. Use naive Bayes algorithm and tell the class of this test instance. So if you have color equals to red, origin equals to domestic, and type equals to formal based on this training data set. Okay, first of all, what do you think about this feature color? Is it a binary feature or it is like any other
Binary.
binary, right? Yeah. So it is having only two choices. One is red and another is yellow. Similarly, type also is a binary feature, and origin also is a binary feature. So and one more thing is so you can say that this is a binary feature with each of them are the binary features. And how many features are there? Three, right? So each x is in which how many dimensions? Three dimensions.
Yes, sir.
Okay. So and your output feature is also a binary feature. Now you can just understand like this is 0 1 0 1, everything is 0 1 0 1. What you have to do is you'll have to find out the probabilities for each of these features, right? And using the maximum likelihood estimate, then you can use the naive Bayes. Now I think I have just simplified this problem. You can try it now. Okay. Yeah, summer. So I think you'll have to go through lectures like 2 or 3 times again and again, right? I understand it's harder. The remaining weeks might feel more harder than this. So I think we'll have to put in a lot of efforts. Uh, so the important thing about understanding it is like you'll have to watch it again at the same lecture. If you don't understand, right, don't rush to the next lecture. I think that is a better thing to understand here, right? It's like it's the same thing. Linear algebra. If you will have to be have that good understanding of linear algebra part, right? The notations actually. It's not like okay. I'll give you 2 more minutes and then we'll discuss, right? Yeah, I was coming to you.
Hello, sir.
Sure.
Sir, the fifth serial number is duplicated, I think. So do we have to consider it two
Yeah,
times?
there are 11. Yeah, there are 11 data points.
11.
But fifth is the same. Both the files are the same. So do we have to consider two or just one?
Oh, I didn't see that. I used 11. You're right. Must be duplicate.
What is it? No is the answer. Okay, fine. Let us see. Okay, I think the answers are not here. Fine. What is the? I think I'll have to write it right. Just give me a minute.
Sir, one observation is duplicated, I think. The fifth observation. Do we have to consider it two times or just one time?
Okay. So what you should do here? I think first of all we'll have to understand the features and how they look, right? So each of these features are actually binary features. So just give me a minute.
Sir, the fifth observation is duplicated.
Ah, that is okay, right?
So we have to consider
Oh,
only
acha,
one,
acha, okay,
no?
okay. I think it is like, yeah, I think it was a mistake, typing error, right? Because serial number also is the same. So I think this was like mistyped. You will have to take only 10 observations in order to get this
Okay,
data,
okay.
right? So I think, see, this is the problem. If it was the another example, that was fine, but I think here the serial numbers are same, that means it's like mistyped, correct?
Answer is coming out to be same in both the cases, so no
Okay.
issue.
Okay, so what you have done is, first of all, uh, we'll have to find out what is the goal here. So first of all, I think, what is the probability that
Yes or no?
y equal to, let's say, 1. Okay, I'm just saying that 1 for yes and 0 for no, right? Given that x test, right? Or okay, generally will have to do the training, and you'll have to find out all the uh, so we'll have to find out this probability. And okay, I need to check what are the first. Okay, we just give me a minute. We'll see the formula here. Not this one, right? What is it? What is this week? Basically, you wanted to use the naive Bayes algorithm. So okay, I think it is not here also. It's there. Okay, these are the estimates we'll have to find out, that we can do. Really, this is the thing we need to do, right? So probability of y test equal to 1. Okay, given the x test, right? That is what we wanted to find. But first of all, how to find out these values, the parameters which are there. So this is what this parameter denotes to what, the
Probability of yes and probability of
probability of
no.
no of the label, right?
Yes.
So like here the label here is satisfied, right? So what is the probability that okay, p hat p hat is, this is okay, p hat is the probability that label is
Yes.
yes, right? In this case, in our case, or I can say 1. And then naturally 1 minus p hat will be the probability that label is no, right? So or 0, but here in this case we don't need to find out both, because one is enough. So what is the probability that label is yes, number of yes labels, right? So summation of how many yes are there out of the total. So how many total are there? 10. 10 examples. And what, how many yeses are there? 1, 2, 3, 4, and 5. 5 yeses. So I think it is a balanced data set. So 5 by 10, which is 0.5, right? This is the probability that the label is yes or no, and this is the estimate for it. What about the next estimate? So this is what for the jth feature,
Mhm.
uh, and corresponding to
Label.
that label, right? So, and that is the probability we need to find out. And how to find out this probability? This indicator variable, right? So indicator that this belongs to class 1, and y equals to 1, right? Like that class is 1, right? So uh, whether this is 1 or 0, that we'll have to find it out. Is that correct? This is the number of emails with label y. And what is this? This probability shows. Okay. With respect to this example, can you tell me, like, let's say color. Color is the uh, attribute we are actually looking at it. There are two classes here, red and yellow. So either we can make red as 0 and yellow as 1, right? Because we are saying that each of the feature here, x also belongs to two classes, and the two classes are 0, 1. And how many dimensions are here? 3. Is that fine? This is how our x looks like, and how this y looks like is 0, 1. That's the training data set we are having. So we are actually having 3 dimensions here, and each of the dimension is 0, 1. Labels also are 0, 1. So this is for labels. What about this case? P, J, Y. So this is actually J is what here? J is the, so let's say it's a jth feature, right? Jth feature, and Y is uh,
Label. Label.
label, right? So it can be 0 or 1,
Yes or
right?
no?
Yeah. Similarly, let's say then what if I say that P1 hat of 1. So what we are considering here, 1 as 1 for S and 0 for no. Similarly, we'll have to consider this, like, probability of, in this case, P11 denotes what? Let's say
Color. Color.
probability that the color is red. Color is red. Is that fine?
Yes, sir.
And color is the variable. So this is indicated by this one, right? This one, this one, and then red is for this. So it's just a coin, right? So it's a Bernoulli trial basically, and what we are saying is this Bernoulli. We are saying that color is the, let's say color is red or yellow. These two are the things, right? So I'm just assuming that for this case, for feature color, which I'll denote here, let's say color, which is, let's say I'm denoting it as 1, and that should be equal to red or yellow. Fine, I can say that red is equal to 1 and yellow equals to 0. You can interchange also, it's not a problem, right? So you can say that yellow is 1 and red is 0. That doesn't matter here in this case. So what is this probability then? Probability of 1 hat 1 is like how many number of
Reds are
reds
there.
are there in the feature 1, and the feature 1 is here is color. So how many are there? 1, 2,
Three.
3, 4, and 5. Correct?
So in one there are only three, sir. In yes there are only three. In yes there are only three,
Okay.
sir.
What is it? Number?
Yes, so 3 by 5, sir.
In
Yeah.
yes
Okay.
label, in
Okay.
yes label
Okay.
there are only three reds.
Sorry. Yeah, we'll have to, because it's two. Both the sides will have to look at it, right? Yeah, correct. So how many yes are there? So this yes, okay. Total 5 yes are there. Among those 5 yeses, we'll have how many rates? 1,
Three.
2, and 3. So the first label, sorry, first example, the third example, and the 10th example, right? Right. So here it should be, sorry, should be
Three by five. Three
3
by
by
five.
5. And you can say that what is the probability that the color is uh, red in the 0, label, when the label is 0, it's 2
Two by
by
five.
5. Correct. Similarly, what is the probability that color is yellow in the jth feature, that is first feature, is how many? So how many yellows are there when S is there? So for yes, you can see that here yes, this is yellow 1, here it is 2, it is 2, right? So it is 2 by 5, and P. Okay, this is something wrong, right? I didn't. What is it? P one
So
of
one you have to write P hat 1 1.
1
P
1.
hat
But this is 1
P
1
hat,
here already, right?
but
Sorry,
that
sorry.
is
No,
1
no.
minus P hat 1
This is,
1.
yeah, yeah,
This
this is
is
1
1
minus
minus
P
P
hat
hat.
1. Sorry, yeah. Is 1 minus P hat 0 1. Is that correct now?
Yes,
It's
sir.
3 by 5. Basically we don't need this part because you just need, so we need to find out the uh, so this is like this we know already, right? So this can be done. We'll just have to estimate only this parameter. So first parameter is the parameter for the label, right? So label generation, and then the second will be for the first feature. So okay, similarly what I can say about now the second feature. So second feature and the uh, if
First label.
yeah, so let's say j equals to 2 here, and let's say y. What is this? Is the, okay, or maybe I'll write down 1. So probability ability that, what is the second feature here? Type. Type is, let's say, casual. Type is casual. So here this type is a second feature. So this is the 2 which is mentioned here, and casual is, let's say I'm saying it's 1. So I'll write down it's again here, let's say type is the variable. Okay, type equals to casual, and what is the next type is formal. Is formal, right? And so casual is, let's say it is, I'm just denoting it as 1 and then it's 0. So now will tell me what is the probabilities. So P2 hat 1 equals to, that is whenever the label is yes, how many casuals are there, right? So that is the probability. So
4 by
yes,
5. 4 by 5.
1, 2, 3, 3 and 4. Yeah, that's it. So 4 by 5, and P2 hat 0 is equals to, now it's like uh, when the
2 by 5.
casual
2 by
is
2 by 5.
no, is 1 by 5, right? So is it when the variable is no and the casual, right? No 1, no 2, acha 2, okay, 2 by 5. Okay, so can we read it again? What was this probability? P1 hat 1 is, it was the probability that when the label is 1, what is the probability that red will occur, right? Correct.
Yes, sir.
P hat 0 1. So P hat 0 1. So 0, I'm just reading it like, so that means when the label is no, what is the probability that red will occur, right?
Yes,
Right.
sir.
Similarly, P2 hat 1 is what? This is the second feature. So whenever the label is yes, what is the probability that casual will occur, right? And similarly, P2 hat 0 is like when the label is 0, what is the probability that uh, the type is casual, right? It's just kind of like that. Is that correct?
Yes, sir.
I hope all of you are fine with these probabilities, because see, I think this is the hardest part only, like to understand this notation and all. Otherwise, there is no problem, right? So this is for getting red, is for getting red when the label is 1, this label is 0. This probability is getting yellow when the label is 1, getting yellow when the label is 0, right? Similarly, this is the probability that uh, uh, it is like when the type
Casual
is
one
casual, and when
when
the
label
when,
is 1.
when label is 1 is casual when label is 0. This is now 1 minus p2 hat 1 is this probability is 1
1 by
minus 1
5.
by 4 by 5 is 1 by 5, and that denotes it is formal
Label 1.
given label 1, and 1 minus p2 hat 0 is equals to 3 by 5 when it is formal and label is 0, right? Similarly, now I'll just write down p3 hat 1 and then the p3 hat 0. And I'm just saying that domestic is equals to, so I'll just say that this feature, the third feature will be, so it is domestic and I think it is international, right? Domestic and imported. Okay, imported. Imported. Ted is origin is the third feature. I'll just say that it is 1 and it is 0. So can you tell me whenever yes is there, how many domestic are there? 1,
2 by 5. 2
2,
by 5.
3, 4. Okay, domestic 1, then 2,
2
and
by
then
5.
yeah, 2 by 5. And okay, when no is there, how many domestic are there? 3 by 5,
3
right?
by
So then 1, 2, and 1, 2, and 3. This one, 3 by 5. And similarly, this is 1 minus p3 at 1, which is now I have
3
to,
by 5. 3 by
so
5.
it is 3 by 5, and here 1 minus p3 at 0, which is
2
2
by
by
5.
5. Now this is okay.
Yes, sir.
Yes.
Okay. Uh, this was clear, right? This is correct, right? And the
Yes, sir. It is correct.
sure, right? Okay. I think it's like it happened that these are the 1 minus probabilities, but it shouldn't be. Yeah. Okay. Done. Fine. So what is the question now? We need to find out if the X test is like this, color is red, origin is domestic, and type is formal. What is the class for the test instance? So what is the algorithm now tells me? We'll have to find out this probability. How to find it out? So possibly you'll do this product and all, right, and you'll have to find out this part. Okay. Uh, what is this probability tells me? First feature, label 1, right? How many it is occurring in the test. Okay, and this is what label. So this is basically for
Probability
label.
of the label.
Yeah,
Probability of the
labels
label.
of yes. So how do I write it down now? I think we'll have done that. What is X test first? X test is color is
Red,
red,
domestic, and formal.
formal. Okay,
Red formal domestic.
red, formal, and say domestic. This is feature one, feature two, feature three. Okay, okay. So and what we have decided for red? Red is label one. Can I say that it is 1? So this vector will look like this, right? 1. Formal is, let's say, 0, and domestic is 1.
1.
1, 0, 1. So I need to find out y test is 1 when the x test, what is the probability of this, and what is the probability of y test 0 given that x test, right? So with the with the Bayes theorem, what you do, you'll have to find out probability that x test given
Given Y test
y test equal to
equal to 1.
1 into probability of
Probability of yes.
y equal to
Y.
1,
Yes.
right? basically, okay, instead of writing that, can I write like this p hat? This should be the parameter estimated for this. And here probability that x test given y test equal to 0 into 1 minus p hat. Is
Yes.
that fine?
Yes, sir.
Okay. What is this probability now? This we know. This is like initially we have done here.
Half and half.
It was
So that
it
will
was
cancel.
0.5. So here it is 0.5. Here also it is 0.5. That's okay. What about this probability? Probability that x test given y test equal to 1. So whenever uh, the labels are 1, so given that the label is 1, what is the probability that x test? That is the question it is asked, right? So for the first feature, so basically it is a product of all this, right? I'll have to write down the product. So the product will be what? So for the first feature, if it is red, if it is equal
3
to
by
1,
3
and
by 4.
3 by 5.
the label is 1. So this part,
3
right?
by 5.
This is the probability we'll have to look into. So it is 3 by 5. So I'll say that 3 by 5 into for formal. So it is
1
formal
by 5. 1 by 5.
and the label is 1. So it is formal and the label is 1. This probability,
1 by 5.
Yes.
okay. So it is 1 by 5 into it is
2 by
domestic given that the label is 1. So domestic is uh, this. So can I say that this probability,
2 by
Yes.
5.
and that is 2 by 5. Okay. Here now if it is red, given that the label is 0, so I'll again go back and I'll check that it is red and the label is 0.
2
So
by
can I
5.
say this probability, which is
2
let's
by
say
5.
2 by 5 into it is formal and uh, the label is 0. So formal and the label is 0 is this
3
probability,
by 5. 3 by 5.
correct? So this 3 by 5 into, now it is domestic and the label is 0. So the domestic is actually denoted by let's say feature is okay. So this is what, this is the probability for, okay, I didn't write it like, okay, I'll write it down. So domestic, we said for domestic as 1, right? So yeah, this is
3
uh,
by
this is actually domestic given label is 1. This is uh, this is
Dom-
again, I think it is
Domestic given
domestic given
label is
label
2.
is
Label is 0.
0, and here it's imported
Imported given label is 1.
given label is 1, and here it is imported given label is 0. So what do you want now? It is domestic given the label is 0, and domestic and label is 0 is this
3 by
probability. So it is 3 by 5. So if you just look at this product, so anyway, this will get cancelled out. Let's say this will also get cancelled out. Now 2 by 5, 2 by 5 will get cancelled out. So 1 by 5 is greater than 3 by 5, or 3 by 5 is greater than 1 by 5.
3 by 5 is greater.
So this is the relation here, and this belongs to what probability? That the
No.
y test is
No.
0, right? So y test is, so that means the prediction is y
No.
test equal to 0, which is basically the label correspond to it is no, right? So the question was what is the class, or whether the it is satisfied or not? No, right? That is
No.
the answer. The customer will not satisfy with the color red, domestic, and the formal. I hope it was fine. All of you understood this part. Hmm? Okay, let's do second question. So x is x1, x2, x3 transpose is a feature vector, and y represents the label in the binary classification problem. Which of the following equation represents the naive assumption used in, what is the naive assumption in naive Bayes theorem?
That the features are independent
Independent
given
of
the
either. Yeah,
yes.
class conditional independence is the naive assumption. So which of these options will hold true.
D. D.
Sure.
Yes,
Yes,
D
sir.
will hold.
D will be the answer, right?
Yes,
What about option A? Is that correct? But that doesn't show me the naive assumption there, right?
yes,
Yeah,
That's a
it is
naive
not.
Bayes. Yeah, this is a normal Bayes theorem, right? What about B? B actually, I don't know what probability it represents there, but yeah, this is not the naive assumption. Definitely, it is given that class. What we are saying that the features are independent to each other, right? So x1, x2, and x3 are the independent features, and option D is the correct answer for this. Okay, let's solve this third question. A Gaussian naive Bayes model. So what is the difference between like the naive Bayes model we have seen now and this question? What is the difference between the binary naive Bayes and the Gaussian naive Bayes?
in Gaussian, the features can have any real value.
Yeah, so it can have so the distribution of the variable is itself is, or the distribution of the feature it's we are assumed as a Gaussian. Okay, and is trained for the multi-class classification problem that has 10 features and 3 classes. Find the total number of parameters that have to be estimated for this model. Consider each parameter to be a scalar value. In other words, if we decide to store all parameters in Python list, okay, that doesn't matter. Okay, so we'll have to find out how many parameters are required to be estimated, right? Okay, take some time to solve this, and then we'll see.
So can you show the question, please?
62, 63, 122, and 132. Okay, 8. Oh, 8. Okay, I'll discard 8. Now let's do it. Okay. First parameter, like if they are we are having three classes, what to do here? How many parameters will be there? So let's say this is the diagram we know. So the diagram, if you see that, it was like we had initially two classes, right? Yes and no. And that's why we needed how many, like there was only probability of success. That is one parameter we need to find it out, right? Currently, we are having three classes, right? So let's say class 1, class 2, class 3. So to how many parameters we need here? So
2.
2, right? So basically it will be like how to write it down, I don't know, but let's say it should be like 3 minus 1, right? That is definitely 2. The third one will be because uh, the probability, right, the sum should be equals to 1. So if I know the two parameters, the third will automatically be there. Is that correct? That is okay. I think that is fine for three classes. Now the question is, okay, we have how many features? 10 features. Okay, find the total of parameters that has to be estimated for this model. Let's look at it for the case of binary features, right? So how to do that for binary features? So if you have binary features, so how many classes? So let's say you have 10 features, and let's say uh, for binary classification problem, uh, we need only like two, right? So we just used to have this part like p0j, or maybe p1j, and here p0, p0j. What is this? For the jth feature, what is the parameter for uh, label 1, right? And for jth feature, what is the parameter for 0? But in this case, if the three classes are there, it will be pj1, pj2, and pj3. Do you agree with this part?
Yes, sir.
For binary features I'm talking about. Okay, and what else will be there? P0, uh, okay, I think, can I say that, okay, how to write it
So
like,
that is the only thing we require, no?
no, see,
P1 1, P2 1, P3 1.
yeah, so I think I'll have to write it like the notation has to be perfect. So basically, see, when you have two classes, what do you do generally? If you have two classes, you'll do like pj in the zeroth side, right? Or the class 1, and this notation is for class, right? And this is pj for
J is
class
the
0.
number of features, right? J is the number of features.
J is the number of features, right? So j is actually j will go from 1 to 10, right? Here j
Yes,
will be
sir.
1 to 10. But this is for this, let's say it was a spam class and a non-spam class. Like we will consider first one class and zero class. In that case, we, for each of the feature, will have two parameters we'll have to find out. Is that correct? For each of the feature, two parameters. Correct, na?
Yes, sir.
So now in the case when we have three classes, let's say 1, 2, 3, how many parameters I need to find it out?
For each
pj1,
feature, three
pj2.
parameters.
Yeah, correct. That's right. And now, so if you have 10 features, how many parameters will be there?
30.
10 into 3, which is 30, and plus the 2.
2.
It is total 32. And this is the case when my features are
10.
binary. 10 features and the binary, right? We are assuming that they are binary. Is it fine?
Yes, sir.
Okay, but now the case is not like that. We are saying the features are distributed like what? Features are distributed like normal with mu and some variance. Okay, and we again have the 10 features. So will this affect these parameters?
No.
No, right? So for three classes, again the same thing will be there because uh, they are the finite ones. What about the features? How many features we need now here? So one feature we need is mu
Yes,
j for 1, mu j for 2, and mu j for 3. Is that correct?
yes, sir.
For the first class, what is the mean, right? For the second class, what is the mean? And for the third class, what is the mean? What about the variance? So, hmm,
Variance will be a 10 cross 10, 10 cross 10
matrix.
matrix. Yes, sir. I think so.
Okay. Okay, fine out. We'll find it out anyway. So let's say, okay. First of all, how many mules are required? That is fine.
50.
30, right? 10 into 30, this 3, right?
Yes, sir.
Okay, that is okay. What about the covariance matrix that we need to find it out? Okay, so covariance matrix will be general covariance matrix will look like what?
3 cross
Suppose
3 matrix.
yeah. So here what will be there? So sigma 1 1. Let's say it is here sigma 1 2, sigma 1 3, sigma 2 1, sigma 2 2, sigma 2 3, sigma 3 1, sigma 3 2, sigma 3 3. If this is a matrix, how to read is what is this? The
Variance between
variance
the first features. Variance of the first feature.
variance of the first feature, right? So basically it should be sigma square. We are just thinking about the standard deviation here, but that's fine, I think. Okay, and what about this
Covariance of first and second
first
feature.
and the second feature, and this covariance between first and the
Third feature.
third feature? So now can you tell me, if you have 10 features, what will be the now parameters? How many parameters we need it there?
10
So
cross 10.
10,
10
10
cross 10.
variances, right? So this matrix will be what? If this is the matrix, so basically it will be starting with sigma 1 1, or I say sigma square 1 2, and it will go up to sigma square 1 10, right? And sigma 2 1 square, sigma 2 2 square, and like sigma 2 10 square. Is that fine?
Yes, sir.
And similarly here it is sigma 10
10.
10 1, that is like I can say that 110 square, sigma uh, 210 square, right? And up to it will go to sigma
10, 10.
square. So basically it is a 10 cross 10 matrix. So how many parameters it will contain?
100.
100. 100, but this is a symmetric matrix.
Yes, sir.
So how many parameters then? So all 10, the variances will be like this. These are the 10 variances, and how many parameters will be there on the upper triangular or lower triangular side? That we will have to find it out. Like I think this will be like we'll have to calculate them, right? Here the
Right.
first row it will have 9, second it will have I think 8, I think 7 6, like that we'll have to go. And what is the sum of it? So sum of uh,
55, I think. 55.
no, no, for 55 is the sum from 1 to how many? 9, right?
1 to
1 to 10 actually. So 1 to 9 is 45. But do you have 1 here? So what is the quantity here?
yes, 1 is there, no, sir. Sigma 1 1 will be there.
Okay, the simple thing, okay, what we'll do is total are 100 parameters. We can remove 10 from there. So we'll have 90, 90 divided by 2. So that will be 45, right? Correct?
But the variances will not be included here,
No, no,
right,
no,
sir?
no, no.
Covariance.
Without this is covariance plus variance. So total is 55. So 45 for covariances, 10 for variances. So total parameter in the sigma matrix we need to find out is
55.
55 plus how many mu's are there?
30.
3 per feature into 10. So
10.
total 30. So I'll add here 30 and plus how many
2.
parameters for this is 2. So these are the total number of parameters. So 55 for sigma,
87.
34 for mu's, and 2 for the class probabilities, right? The class or labels, right here. Let's say labels. Is that fine? So I don't know what is the 85 plus 2, 87
87.
features. So that should be the answer. I whatever your answers. Okay, I think. But do you feel that this is the correct approach to solve this?
Yes, sir. Yes, sir.
All of you agree?
I did not consider, because it's a covariance matrix, it is symmetric, that I did not consider while calculating.
Yeah. All of you agree? Just can you just thumbs up, because this is if somebody don't like, will you can just ask me now. Okay, done.
So,
Uh,
what is the significance of the last statement?
which one? Which
Uh,
statement?
the last statement of the question.
Okay, the question. Okay, what is it like? Focus on the parameters of the class conditional densities.
Ignore priors in the calculation.
Ignore the priors, right? So I think, see, in the naive Bayes theorem, right, we are actually considering that each of the what is it like? What is the naive Bayes theorem? So it will have the maximum likelihood into the prior, right? So prior will be the probabilities for the parameters, right?
Yeah.
So we don't have to consider, we don't have to worry about their their distribution also. So here what we are actually doing is the Gaussian distribution, we are actually doing it for variables, right? The features, for example, right? So the features are distributed according to the Gaussians. In priors, what happens is priors actually we consider in the prior thing, we consider each of the parameter itself is a variable, right? So this the parameter estimation we are doing, we don't have to worry about it. I think that is the meaning of it, but I'm not sure. Like, so the person who has done that, how does it will affect your parameter number of parameters? I'm not sure about it, right? But
So
the thing is,
does it mean that we don't have to include the initial two parameters, initial two
no, no, no,
parameters
no,
that
no, 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 no. That is a different thing, right? What is the prior thing? If you remember from the stats 2, so basically what happens is the posterior density will be depending on your uh, likelihood and
right.
into the prior density, right? So the so if I just take the simple, maybe let's say take the Bernoulli distribution, what will be its likelihood? The p to the power, let's say w, and let's say total n number of examples are there, and p to the power w is the number of ones in the that like sample, into 1 minus p to the power n minus w. Then what we say is that like p is not a constant, right? So when we don't consider the prior, that in that case we say that prior probability of success is a constant. Now we are saying that prior is also having some density, and let's say it is the density is the beta density. So what happens here is p to the
Alpha
power
minus
alpha minus 1 and 1 minus p
one
to the
minus
power
beta.
beta minus 1. So now because of that, we can have these two more parameters, right? This alpha and beta, correct? See, you're understanding the point.
Yes,
So
sir.
we'll have to ignore this. It is nothing to do with this part, this part, right? The class conditional is not about the thing, right? So this is coming from a sample here. In this case is a features. If you think it carefully, uh, what else is here, and how does this is coming from? This p, this is from the labels, right? So label is also one of the features, right?
Yes, sir.
Like consider, if you feature in the sense it's a variable, so this variable in the label also will have some distribution there. So I think that is the meaning of it. I don't have to think about like I'm not sure what is another way of looking at it, but this has to be the way. Okay, I think it is saying that you don't have to worry about the other two things. Okay,
So
let's
those
move.
two have to be included, no? Two have to be included,
Yeah,
no?
yeah,
Right?
yeah, definitely, definitely, yes. Okay, you have trained a naive Bayes model on a data set with two classes, which is positive and the negative sentiment. Okay, so that means like there is a zero class and there is a one class, or minus one one. You can consider anything. For a new instance, the model provides the following conditional probabilities. Probability that x1 equals to x1 given it's positive. What is this? The first sentence. How will you look at it? Y equal to, so positive is y equals to 1, let's say, right? Plus 1. So probability that x1 equals to x1 given that y equals to 1 is Point 0.6, probability that x2 equals to x2 given that y equals to 1 equals to 0.5, like that. And the prior probabilities of positive is 0.4. What is the posterior distribution? Okay, you'll have to find out. Take some time to do it and then we'll discuss it. Okay. What's okay? Only one that's solved, but that is like two different answers, right? Fine. We'll wait for 1 more minute and then we'll see. This is easier one, right? Is this? I don't think this really very tough. It's just multiplication, right? No? Okay, fine. So I can see Priya, it's 0.3, 0.25, 0.44, 0.3. Okay, fine. Okay. Shall I solve this problem? If you guys are not trying it, maybe I can just do it, or if you want, then I'll just wait.
Yes, please.
Okay, only two people who are saying that those who have given the answers. What about others? Are you guys trying? No
Yes,
response.
sir.
So shall I solve it or I'll wait?
So I need 1 minute, sir.
Okay, okay. I'll wait for them. 1 more minute. Okay, I think shall I solve now? Like, okay, maybe I'll start writing down all of these things which are written there. How many features are there? X1 and X2, right? There are two features and there is label Y here. Okay, I think that's fine, right? Okay, and you have two values. So let's say you have x1 and x2 and y. Okay, and then when x1 is equals to some value of the feature, given that, and y belongs to two class, so it is, let's say, 0 and 1. So I'll say that this is a negative class, and this, or maybe I'll just write down -1 plus 1 to differentiate -1 and 1. Okay, positive and negative class. What is given to me is that probability that x1 equals to x1, given that y equals to plus 1, and probability that x1 equals to x1, given that y equals to 0. Uh, what are this probability? Can you just tell me? About that x2. Okay, probability that
0.6 and 0.2.
just a minute. X2 equals to x2, given that it's positive, provided that x1 equals to x1, given equal to 0, that x2 equals to x1, given y equal to 0. Okay. If in our terminologies, how to write this parts? We generally write pj, right, and j equals to 1 and 2 here, pj1, right, and that is equals to this, right? Is it correct? I'm writing whatever I'm writing, or
Yes, sir. Yes, sir.
fine. So we'll not dive into that. Let's find it out first. What is this? What are these properties? Can anyone of you tell me this 0.6, this
0.5.
0.5, this about this
0.2 or 0.3.
0.2,
0.2. 0.2 and 0.3.
yeah, 0.2 and 0.3. Okay. Okay, and what are the prior probabilities? Prior probability for the positive class. Okay, I'll just write. I have written here -1 and -1. So probability for the prior is how much it is? 0.4. That gives me probability for negative classes 0.6. This is the prior probability. So we'll have to find out the posterior for each of the class. So let's say for uh, positive class, what is the posterior probability? So posterior is directly proportional to what? Likelihood into prior, right? So likelihood is basically the product of all the let's say if I am just talking about the classes, so basically this will be this probability into this probability, right?
Yes, sir.
So these probabilities will be 0.6 into 0.5 into prior probability will be 0.4. This is for class 1, right?
Mm.
And if I'm ignoring the thing that will have to divide also, right? So that is okay. So let's say if I ignore that part also, they are not ignoring actually, but yeah, this is for posterior probability for class, positive class. And what about negative class? It will be again, what is the likelihood here? Zero point 0.2 into
0.3.
0.3 into 0.6.
0.6.
So if I just calculate, it is 0.3 into
0.12.
0.2.
0.1.
Here it is 6 into 6.36. Is that correct? So what are your values? What do you feel? These are the correct probabilities?
0.036 will be there, no, sir, for second one.
6. This is, yeah, 0.0. Yeah, correct. So it is like this 0.06 into 0.6. So three decimals, right? Yeah, that's true. 0.036. Sorry. This is 0.12 and 0.036. Okay. I hope this is fine. That should be your answer. Anybody has gotten this answer? No one? Okay. I think the four probabilities will not come, right? Only two will come. I hope that is fine. because we have only two classes here. Okay, I think how many questions are there to this? We'll have so many. Let's try to finish it as fast as possible. Okay, a Gaussian naive Bayes model is trained on a given data set. For an unseen data point x, the following two values are calculated as okay, probability that x given y equals to 0 is zero point 0.4 and probability that given y equals to 1 is 0.6. What will be the predicted label for x? What do you think about it?
1.
1, right? Because it is having the higher probability, so it's 1. Is that correct?
Yes, sir.
All of you are fine?
Yes, sir.
Yes, sir.
It doesn't matter whatever naive Bayes model, like normal naive Bayes also there, and if these are the probabilities, we don't have to worry about it, right? Whichever the probability is greater, we are anyway going towards that. So the predicted level for x will be 1 here. Okay. uh, so if you know the distribution of probability of x comma y, what is this? The joint distribution between x and y. Can you always find the distribution of probability of y given x for the same data set xy?
We should know the prior, sir.
No, I think prior will okay. Prior is not required. Let's say you don't have to worry about prior. How to find out this joint distribution? Like how to write down this probability of x comma y is basically probability. We can write in two ways, right? What are the two ways?
Y given
Probability
x
that,
into x given y given x,
so let's say okay,
x
x
given y
given y
into
and the probability of
probability of
y,
y,
or
or p
probability that
probability of y given x
y given x into
into
probability of
probability of
x.
x.
So if I just approach this problem, if I know this part, can I know this part if I have the data set?
Yes.
Because this is a distribution of labels, right? How many labels are there? Can we able to find out? I think this is the question, right? Okay, I think what is the question? Is the question is we need to find out this part, right? Okay, but I think if I have this distribution, uh, will I be able to find out probability that y given x every time? Hmm? So can you always, the question is, can you always find the distribution of probability that y given x?
So unless we know probability of y,
Uh,
how can we find out?
but for probability that y given x, you need to find out the probability of x also, right?
Yeah, yeah, yeah.
But you'll have that training data with you, right? All the data set and the labels will be there. Okay. I think we will be able to, right? So if I know, let's say all the emails and their labels, if I know their joint distributions, like uh, I think we'll be able to. But okay, this is a tricky question. Maybe I don't know. That always gives like some issues. Okay, maybe okay. Don't worry about it. I'll just find it out. I think I'm not also having the answer this time. Let's I'll properly discuss this problem. Right?
Probability of x is the sum of the probability of probability of x is the sum of the probability of x given y equal to 1 given probability of y equal to 1
Yeah,
plus
mistake.
the
Yeah,
probability of x given y equal to 0 into probability of y equal to 0. So if you know probability of x, then we'll be able to find the probability of y given x, because we already know what is probability of x comma y.
hmm.
So probability of y given x, you can, I think it is yes.
Yeah, even I think so, because you have to just get the marginal, that is integrate over y or integrate over x. No? Get the marginals.
No, we need to find out the conditionals, right? And we know the joint distributions already. Yeah. So you need to find
Yeah.
out the marginals.
Yeah.
Yeah. And I think we will be able to do that. Still, okay. I think that's correct, but that's I'll check cross check once more again, right? So I'll give some thought over it and properly maybe the next session or somewhere I'll just discuss about it. Okay. Yeah. Let's. Mm, I think we'll do this question little later. Just try to answer this question. Suppose you want to use a naive Bayes classifier to predict the gender, uh, whether it's male or female of a person based on two features: their height and their and whether they are like above 20, right? So that means the age, right? So height and age is the I think that these are the two features, and your label will be male or female. Assume that the features are conditionally independent given the gender of the person, and that the variances of the height and okay, so variances are equal. How many number of parameters are required to classify a new example using the naive Bayes classifier? So one more thing to understand here is height and age. You can think these two variables as what? What
Height is
equation?
a height is a Gaussian, right?
Yeah, so generally
And
height and age. Age also you can consider
age
as
is
age.
just plus or more above 20 or not. So it is just binary, I think. If it is above
Yeah,
20 or
so yeah, okay, yeah, above 20. If it is written
Yes.
above 20, yeah, I
it
think
is
the
binary.
only two, yes or no, kind of, right? Fine,
Yes, sir.
okay, yeah, that is so the age might be a binary feature here, and height will be
Height
your
is Gaussian.
Gaussian, like yeah, Gaussian distributed. So how many parameters you need to classify a new example? Just takes like 2 or 3 minutes to solve this, and then we'll see that. It's a similar kind of problem which we have seen earlier. The only thing here is, uh, I think we are considering one Gaussian distributed feature and another as uh, binary, right? Okay, is it done? I hope it is done. Okay, so okay, what I will not write it. Maybe can you just discuss it? Okay, so uh, okay, maybe I'll write it down. Maybe it's not a problem. So you have let's say two features, which is x1. I'll say height, and another is x2, which is age, right? And then you have labels. So labels are, I think, binary, 0 1. X2 also is a binary case. So for labels, how many parameters we need to define? Like only one, right?
Yes, sir.
For age also, it's like it's also binary, so I'll need only one. But
One for each label.
one for each, right? So that is one. Let's say pj one, and let's say pj zero. Is that fine? Okay.
Yes, sir.
What about the height? It's Gaussian distributed, but that means you need to find out mu. Uh, let's say mu
U1,
j
U1 and
j, yeah, and mu j zero. And what else? Sigma one, sigma j, uh,
it
one
is same for
one
both the
square
features.
one. And will it be same?
Sigma is same. Sigma is same.
Is it said here? Okay, the variances of the height distributions are equal. Okay, done. So that means you need to find out only one parameter here. So how many parameters are required? One plus this two plus this two plus one. So total six parameters, right? That should be the correct answer. Yeah, I think all of you are given the correct answer to this. Let's try to find it out this part. Consider probability distribution over xy where features are one dimensional, and okay, and these two are binary. Uh, okay, and let x given y equals to 1 follow uniform distribution over 0 to 4, and x given y equals to minus 1 follows uniform distribution over 2 to 4. Question 1 is, if this is the product of success, is point 4, what will be the prediction for the point x equal to 3 using base classifier? Can you just find it out? Just take 2 minutes to solve this and tell me. Uniform distribution, what are the probabilities? 1 by 4
One
for,
by B minus A.
yeah, 1 minus 1 upon b minus c. So 1 by 4 and 1 by 2, I think it will come out. X equal y equal to 1 and y equals to minus 1. So it's like it's very simple, right? We'll just have to multiply these two. I'll give you 2 more minutes and we'll discuss it again. Is it done? Okay. Let me solve this then. It's easier. This one is easier. Since you have only single feature, so basically the data set will look like this, right? So x and y, only this thing, and y will have 0 1. So let's say for uh, probability that x given y equals to, or maybe 0 1, it's like minus 1 1 equals to 1. How much it is given to me? It is a uniformly distributed, so it's like the distribution is uniform between, okay, so I'll just,
0 and 4.
yeah, it should be like this, uniform 0 4, right? And x given y equals to minus 1 is uniform in 2 and 4. Okay, is that correct? So for positive class, what will be the probability? It's like probability that x given y equal to 1 into probability that y equal to 1. Is that correct? From the Naive Bayes theorem is what
Yes,
we are looking at it. So what is this probability?
1 by 4.
This 1 by 4 into probability that y equals to 1 is how much?
0.4.
0.4. So it is 0.4. So basically it is zero point 0.1. And for negative class, what will be the probability? So it will be probability that x given y equal to minus 1 into probability of y equals to minus 1. So when what will be the probability of y equals to minus 1? It is probability 1 minus probability that y equals to 1, which is zero point 0.6. And here it is given to me as 1 by 2. So basically this will become 0.3. So which is the largest probability among these two? This one, and hence the class will be a negative class, right? I think all of you have done that fine. So yeah, so let's dive into the second question. Okay, so let x equals to 2, and let p had be the estimate for this product of success for let's say y equals to 1, the class 1. Uh, Find conditions on p hat such that the Bayes classifier predicts 1 for this x. Okay, so that means you need to find out what the decision boundary here. So you can just find it out. What is the case? Just take 2 more minutes and then we'll see. You have to use the information from the previous question. Okay. Okay. Shall we see this? Okay, so let's say D is answer from two ways. Let's say what is the thinking here. So if you see the distribution here is, uh, and okay, what is this p hat actually? What is the prediction for p hat here? P hat is for
Y equal to 1.
1, right? So that means the class. So we have to find a condition that the Bayes classifier predicts 1 for x equals to 2. So we'll have to look at into this conditional distribution. So what is the conditional distribution for y equals to 1 when x equals to 2? And the question here, the tiebreaker is predicted as class 1. So what do you think about it? Does it affect, okay, first place, does this distribution of x affects the p hat here? That is the first question.
It is given the p hat, na, given the feature, so distribution is not affected.
Yeah. So what about this part? That
And
so
that remains the
it,
same.
it it will include 2 here also and here also. We are right. So both of the intervals include 2. Uh,
So one will be 0.25 and the other is 0.5.
yeah, 0.25 is this for this part, and 0.5 is this part. Then how will you decide that this p hat? Okay, what should be the p hat? Should be greater than or less than? What is it?
If it is 1, then the 1 should be greater than 0. The probability for 1 should be greater than 0. So if p hat into 1 by 4 should be greater than 1 minus p hat into 1 by 2.
Okay, I'll write it down. Whatever you think. Yeah. Okay, so basically what we wanted is we wanted to say that probability that x equals to 2 given y equal to plus 1 should be greater than probability that x equals to 2 given that y equal to minus 1. Is that correct?
Yes, sir.
Then only it will predict as a class 1, right? That is the part. So what we have to do here is we need to find out what is probability that x equals to, or what is it, how to write this down, possibly y equals to 1 given x equal to 2 into, or no, I think we shouldn't write this. Okay, maybe we can actually write like this, right? So we find out p hat here
Into 1 minus p hat.
into 1 minus p hat, sorry, yeah, 1 minus p hat. This probability we'll have to think about it right now. So what is this probability?
1 by 4.
Is 1 by 4 into p hat is greater than equal to or greater than, right now, and it
1 by
is
2. 1 by
1 by
2
2
into
into
1 minus p hat.
1 minus p hat. So if I use this p hat by 4 is greater than 1 by 2 minus p
P
hat
hat by
by
2.
2. So basically how this will work out, let's say it will go to this side, so p hat by 4 plus p hat by 2 greater than 1
1
by
by
2, and then this will become what, if I just
3
multiply
by
this
4
with
p
3
hat by
divided
2.
by 4 greater than by 2, and p hat should be greater than 4 by 3 into 1 by 2, so basically 2 by 3. So it is said that in the tiebreaker case, so I think that should be fine, that it should be this part. I hope this is fine for all of you. This is the this is the algorithm, right? Like algorithm's last step for naive Bayes, if you remember it. I'll just show you part possibly. This is the case, right? And we have used this case only to uh, showcase that this can be happened. Okay, let's solve this last question here. What about this? If p equals to uh, is estimated to be 0.5 using MLE on a given training data set, what will be the training error of the Bayes classifier for this problem? Do you understand the question here?
Yes, sir.
Oh,
So it will be 0.25, sir. Just minus
minus of what?
0.5 minus 0.25.
This is what given to me is estimated. So this p hat is given to me as 0.5 using MLE, and we'll have to find out the p hat using the Bayes classifier, right?
We have to find it. Okay.
Is that correct?
Yeah, 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 yeah. Correct, sir.
So what is the prior probability here given to me?
Point 4.
0.48, and this is the MLE estimator. So basically MLE estimator is coming from what? Okay, you just do it and then we'll discuss maybe possible. It's fine. All of you understood this problem, right? I am. What is the problem here? So what are you finding here? Can you just tell me once? Then maybe I'll see that. Did you understand? Yes, yes. Go ahead. Yeah, tell me. What are you solving for? First of all, let me know. Then only
I
will.
think that we are finding the training error, sir. That means the original estimated, the trained value minus whatever is currently obtained using the estimated value of p to be 0.5.
So what are you going to find it out now? Okay, training error. Let's leave it. First of all, what are you finding out currently, and how are you finding it out?
So probability of x given y equal to 1 into probability of y equal to 1, which will be taking as 0.5. And probability of x given y is equal to 1 is from the distribution, uniform distribution.
Mm,
So that will be 1 by 4 into 0.5.
I think this is not a question. This question is. Okay, I don't know. Like I'll have to. I'm reading it again. But what if y equals to 1 is estimated to be zero point 0.5? What will be the training error of the Bayes classifier for this problem? I don't think this is the what is this asked here? I'm not able to understand.
I think from 0.4, if it is changed to 0.5, what will be the difference? Is that what it is?
So it will still remain -1 only. So there will be no error. Uh, the uh, uh, the test data will still get
No, no.
-1
We'll
only.
have to know that first place to understand this. We'll have to know that what is the actual distribution of y, right? Like how the classes are distributed.
Point 4, no, sir.
Classes are distributed as zero point 0.4. Okay, this is zero point 0.4. Yeah, this is, let's say this is the correct estimation. Like the point 0.4 is okay, but this is also the estimator. Okay, but let's consider this as zero point 0.4. But this is by using the base classifier, right? Mm, and is estimated using the MLE. What will be the training error of the base classifier? No, no, I don't think of mm, I don't know. I'm not sure like whether this is the true thing or not. Like, what will be the training error? If I think about the training error, it will be like it should be number of classes misclassified, right? Using the naive Bayes classifier. That should I can think of the training error, and that means I should know the correct labels, like how they are distributed, and I should know what is the distribution of y using the naive Bayes classifier, right? Okay. Mm, okay, maybe I'll skip this problem. Means like I'm not sure like whether how to solve this or not, right? So, do you get a sense of it? Like, do you think this is a sensible problem to solve, or I'm not getting the sense of it. At least not now. Okay, maybe okay. If you are able to solve it, let's solve it. Maybe we'll see whether. Uh,
The the probability of 2 to 4 here will not change because it will still be -1 only. The label will still be -1 only for any test data, even if the probability of y equal to 1 is 0.4 or 0.5. Still, the label of any test data will be -1 only, given if the test data is between 2 and 4.
no, what is it saying here? This third is what like. I, how you're saying like what is the value of x?
The value of x will not change. It's only the feature distribution is not changing. It's only the parameter classifier parameter is changing.
Yeah, that is true. So the let's say MLE parameter is this, right? So this is like zero point 0.5 is the MLE estimate, right?
Mm.
Similarly, let's say zero point 0.4 is the MLE like base classifier estimator. If I just think of this as the estimator, right? Is that
Mm.
fine?
Yes.
But where is the actual distribution of y? How will you say that how many uh, classes are misclassified, or which one is the fine distribution? So both of these are the estimators, right? Anyway,
Mm.
no.
I think we
No
can
test data
maximum
is
ratio.
misclassified, sir. No test data is misclassified.
We don't have to worry about test data point, right? That is what my point is. Is that correct? The question is what will be the training error? Okay, how will you find out the training error anyway? Generally,
You have to subtract um, the
so, okay.
the
So maybe so my understanding of this question is like this. Maybe I'm wrong. I'm not sure about it. But let's say you have this. Let's say one feature is there and the labels are there. These are the true labels, right? Let's say you have some values, maybe 2, 5, 6, 8, like that, and you have corresponding labels. Let's say 0, 0, 1, 1. Fine. And you have the estimator, let's say parameter estimator from the naive Bayes. Let's say this is naive Bayes and p hat mle. Okay, by using these parameters you have predicted some labels. So suppose this is from naive Bayes and it has predicted 0, 1, 1, 1. Okay, Similarly, it is predicted MLE. It is predicted for this training data as like 0011. Fine, right? How do you find the classification error for naive Bayes? Will it be like how many classes it misclassified, right? Might be it is 1 by
Yeah,
4
one out of
and it will
four.
be
Yeah.
0, right? Is that fine?
Here none is misclassified. That's what I want to say.
Where?
Here
In the
in this
point 5.
problem,
Yeah, this is
none
this
is.
problem is fine. But how can you say about this problem?
So any data, if it is between 2 and 4, it will not be misclassified. Even if Py equal to 1 is
Yeah, yeah, that is
0.4
okay. Okay. Yeah, yeah,
or
that's
Py
true.
equal to 1 is 0.5, still any data between 2 and 4 will not be misclassified. It will be still minus 1 only.
But what
Table
about
will be
0 to 2?
0 to 2 is can never be minus 1, right? It will always be in y equal to 1 only because y equal to minus 1 contains only between 2 and 4.
No, that is the distribution given to us, right? Actual distribution. No? Okay, I'll get a sense of it. Let's say, suppose you have x between what is it 0 to 4, and the corresponding labels will be what is it, plus, right? Is it like that? No, I'm not sure about this part actually. So let us try to find it out. This is your x, right? You have, let's say, from it is going from 0 to 4 somehow, and the so this is the distribution for, it's either probability, and this is the distribution for positive class, and between 2 to 4, so it will be like little bit higher. Fine, is that fine? It's 1 by 4, and this is 1 by 2. Is that correct? Now this is the distribution for negative class, right? Mm, so when product of 5 equals to 1 is estimated to be 0.5. So basic base classifier prediction will be like this: probability that x given y equal to 1 into p hat and greater than or equal to that, and that 1 minus p hat. Okay, so you are saying that if this is 0.5, this also will be going to be 0.5. In that case, this distribution is not changing, and this distribution also is not changing, right?
If you substitute 1 by 4 here and 1 by 2 here,
Mm.
the right hand side will be greater than the left hand side, which was the case earlier also.
And for each of the for every data point, it will happen, right?
Between 2 and 4 it will happen
This
because 2 and 4 is the y equal to minus 1, and for 0 to 2 it will
yeah,
happen only when y equal to
yeah,
1 is there.
yeah. So when x is between 2 to 4, this is bound to happen, right? This is going to be like it will always give me negative class,
Minus 1 only.
and for between 0 to 2, it will always give me positive class because there is no
Y
distribution of.
x given y equal to 1 minus 1 will be 0.
Hmm, hmm.
X given y equal to 1 will be minus 1 will be 0 for 0 to 2.
So it will never misclassify, right? You're saying,
Yes,
and
yes,
that is correct, and that should be then the training error should be 0, right?
yes, sir. That's what according to me, otherwise,
Yeah, yeah, no, that is correct. I think that is fine. Okay, but I think so. I don't know. So if you guys understood this part, that's fine. Otherwise, I'll just make a proper answer to this, and I'll show you later on. Fine. So we are actually, so there are few more problems are there, but I think the time is up. So I'll share this PDF with you. You can solve this, and if any doubts are there, we can discuss later on. Right? I think these are all numerical type of questions. Just try it from yourself. I'll attach this to the session link also, like whatever session today we had, and also I'll ask them to share in the supplementary contents. Fine. Okay. We'll stop it here now. It's already 10:15. So yeah, if any discussions will be there, we'll do it later on.